Okay, so solve by graphing systems. That's the first flap. So open that up. And a few things actually got cut off whenever I copied this. This should say, and I can barely read it, it should say one solution. One solution. T-I-O-N. Okay, one solution means that the lines cross at one point. That's what that means. We're graphing lines. We're graphing equations. One solution means they do cross at one point. So, I want you to take your coloring pencil, whatever color that you had, and I want you to highlight your y-axis. Because the y-axis is always the one we start on whenever we are graphing our equation. So, highlight your y-axis. Yep, we're in the very first flap at the top. And then I also, here's your system. This is a set of equations, and in this problem, they're already written in slope-intercept form, which is good. I want you to also take your highlighter, and I want you to color in the constant, which is the letter B in slope-intercept form. So here's my constant. It's a -1. I'm also coloring in that sign because that matters. And down here, the constant is a +5. So that tells me kind of whenever I'm graphing where to start. That's my y-intercept value. Now, we're going to take our pencils and we're going to go ahead and graph this very first equation. Okay? So we're going to graph the first equation, noting that this is your y-axis. So I start at a -1 on that y-axis. So find a -1 on the y-axis and make a point. And then this -2 tells me what? Does it tell me to rise to or fall to?
Fall to.
Yes, according to how we learned this, we want to fall to and run 1. And Joe only runs to the right. So we want to make little notes of that. All of this are things that we've learned already, but now we're putting some things together. So from our point of starting point at -1, we want to fall to, run 1 to the right, put a point. We're also going to fall to, again, we're going to continue this pattern. Fall to, run 1 to the right, another dot, fall to, run 1 to the right. Now, as before when we first started graphing, we want to continue this same pattern up the other side of your graph. So instead of fall to, run 1, how do you go opposite of that?
Rise to.
Yes. Rise to and left 1. We know that Joe doesn't run left. However, to get back on our grid, sometimes we have to go opposite. So rise to, left 1, dot. Rise to, left 1, dot. Okay? And then I'm going to connect my dots to make my line. Well, it's kind of crooked, but I'm trying. Okay. So there's the first line. You're halfway finished with a problem. Okay, because you have to graph both equations and see if they cross. And we already know that this one should cross because it's a one solution problem. It should cross at one point. So now let's graph this one. This one begins at a +5. The y-intercept is a +5, so let's find it. Put a point. Okay, and then the slope on the second equation, there are no numbers, so what do you put in place? 1. So put 1 and then 1 on the bottom. So that means I rise 1 and I run 1 to the right. From this point that I just made, I'm going to rise 1 and run 1 to the right, put a dot. Rise 1, run 1, put a point. Then to go backwards, I fall 1 and go left 1, put a point. Fall 1, go left 1, put a point. Look, I ran into the other line, which is what you wanted to do. Fall 1, left 1. I'm just going to put a few more dots on there so that when I draw my line. So, this system of equations has one solution. I'm going to take my highlighter and I'm just going to kind of put a little circle around it. There is the point at which both systems are solved. They share that one point in common. They have that one point in common. Now let's name that ordered pair. What is the ordered pair? What's the address of that point? You find the address by putting X, Y. This is like plotting the point, making the picture of the elephant, or the whale, or the apple, okay? So what's the ordered pair for that?
2, 3.
What type of 2?
-2.
-2 and 3. So this has one solution. We know that. The solution is -2, 3. That's where the two lines intersect. And you're finished with that problem. Now, was that too awfully difficult? No, not if you know how to graph. If you're unsure how to graph, I can see how this could be really frustrating for you. So make sure we know how to graph these. Let's look down at the next one. The next one gives us a little hint here that says no solution. So if this only had one solution because they crossed at one point, are these two lines going to cross at all? It says no solution. Let's check to see. First thing I want you to do is highlight your y-axis. That just helps get us a visual on where do we start. We always start on this axis. And go ahead and color code your y-intercepts, which is your constants or your letter V's. So the first one says it starts at a +1, so let's find it. On our y-axis, which would be here. The slope is a 3, and if there are no numbers under it, you can put a 1. So that means Joe has to raise 3 and run 1 to the right from your starting point. So from here, raise 3, run 1, put a dot, or a point. Raise 3, run 1, put a point. To go backwards, I have to fall 3, left 1. Fall 3, left 1. And then connect your points to make your line. And then I'm going to graph the other problem. A -1 is my starting point, which would be here. And I have the same slope of 3/1. So rise 3, run 1. Rise 3, run 1. And then I go off my grid, so I'm going to go backwards. Fall 3, left 1. So this is my other line. Notice that they kind of look like railroad tracks, which means they are what type of lines? Parallel. So let's mark right here, a little star note, and they would form parallel lines. What do you notice about the slopes of these two problems? When you run into problems that have the same slope, they will form parallel lines. Okay? So, let's put another little note that says they have the same slope. Algebra people, if they have opposite slopes, what happens? They form perpendicular. That means they cross at 90-degree angles. Okay? So, if they have the same slope, in this case, they're going to be parallel lines every time, which means they're going to have no solution because they never touch each other. Okay? Now, there's one more type of problem, and it's on the back of that, in that same area, in that flap. And it says infinitely many solutions. What does infinitely many solutions even mean?
It never ends.
Okay, that's true. Infinite means that they never end. That means every spot on one line is also on the other line. This is like where one line lies on top of the other line. So we're going to use our two colors, okay? First of all, let's look at this. Is this one already in slope-intercept, y = mx plus b? Yes, that one is, but what about this one? We need to make this y equals. How do you do that? Add x to both sides. So you can write this down, add x to both sides. Y equals. I know that I can flip-flop these around in any order I want to as long as I keep the signs of them. Okay, so this would be a positive x. And it says -3. So now that I look at these, I notice that they're exactly the same problem. If a line is if an equation is exactly the same as the other, you should be able to graph them and they'd be exactly the same. So every line, or every point on that line, is a match for the other line, which means there's infinitely many solutions because do lines ever end? No, lines go infinitely in both directions. So let's go ahead and take our highlighters highlight your y-axis. Highlight your constants or your b's, also known as your y-intercepts. Okay, -3 is where you're going to begin on that yellow line or orange line, depending on what color you got of your coloring pencil. -3. The slope, there are no numbers, so you put ones. So rise 1 and run 1. And Joe only runs to the right according to how we learned this. So I'm going to continue on in both directions. I like when my slope's 1 because it's easier for me to graph. Now I'll draw my line. And then I'm going to take my coloring pencil. And this is a -3. So again, I'm going to start on the -3. And my slope again is still 1. So rise 1, run 1. So every single yellow point matches my pencil point or my ink pen. So I'm just doing this to show you that every single thing they have in common. Everything on the yellow line is also on my ink pen line. Okay, exact same equation. So you're going to practice a few of these. Actually, you're going to practice 18 of these because the more you practice, the better you're going to be at it. So we're going to practice these. I will do the first few together. Or up here, you don't have to work with me if you don't want to, but I will be doing the first few so you can kind of check yourself and see if you're on the right track, okay? So, let me get everybody a copy. If you want to, you can go ahead and put this away if you need it. Hang on to it. I would fold it over kind of like this, and then it sticks down into our pockets that we made. This one was a pink pocket that I made. But make sure it goes in there so that it doesn't fall out and you lose